A real repair invoice for a Tesla Model 3 once sparked intense discussion across the internet. Revealed by the American professional agency Current Automotive, this receipt showed that even for a relatively affordable Model 3, the material cost of a bare battery alone was as high as $13,500. With labor costs included, the total bill approached $16,000. The chemical degradation of power batteries is an irreversible physical law. When they reach their design lifespan, they will eventually face replacement. But behind such high replacement costs, very few people know that a serpentine liquid cooling plate hidden deep in the chassis, costing only $90, is the true safeguard protecting your investment. Why is battery thermal management so critical? It's like a person running under the scorching sun. If you don't sweat and cool down in time, your body system will completely shut down. The same goes for power batteries. Their optimal operating temperature range is strictly limited to between 25 degrees Celsius and 30 degrees Celsius. Once the vehicle is in a state of continuous high-speed driving or high-power DC fast charging, the cells will generate a massive thermal load. If this heat cannot be dissipated in time, it will not only accelerate battery aging, but also greatly increase the risk of thermal runaway. To efficiently remove this heat, serpentine aluminum plate with a wall thickness of only a fraction of a millimeter are densely integrated into the gaps between the cells. From an engineering design perspective, the shape of the liquid cooling plate is never fixed. Instead, different serpentine plate must be flexibly selected based on the available space of different battery packs. For example, for the traditional CTM, cell-to-module architecture, or the more highly integrated CTP, cell-to-pack architecture, liquid cooling plate are specially customized into matching plate designs and flow channels. Its core relies on the multi-port extrusion, MPE, process, which can effectively increase the internal heat transfer area within a limited layout space, improving the overall heat exchange efficiency of the system. In practical applications, power batteries are mainly divided into different forms, such as cylindrical, like 21,700 and 4,680, and prismatic cells. The battery packs of the former usually contain thousands of individual cells, while large-capacity prismatic cells mostly number in the hundreds. Engineering data shows that no matter which form it faces, this liquid cooling system can strictly control the temperature difference among these hundreds or thousands of cells within the battery pack to around 3 degrees Celsius. Compared with traditional air cooling, this liquid cooling system can effectively increase the overall cycle life of the battery by 20% to 40%. This is the true value of engineering. A microchannel plate costing less than $100 through rigorous thermodynamic design firmly supports the full life cycle value of that $20,000 battery. If you want to dive deeper into automotive thermal management knowledge or get professional liquid cooling system solutions, welcome to visit our official website at xdthermal.com. Thanks for watching, and see you next time.